Hello, today we're going to talk about log functions. We have a new function and this will be our final new function to learn about this year. So very exciting. So we are going to be learning about the log function, which is the inverse of the exponential. So let's refresh our memory on what the exponential function graph looks like first. Remember that on the other side, when we raise this to the first power, that's going to be 1/10. So I'm just getting some values here. So negative 1, 1/10, 0, 1, 1/10 is going to be way up here. Okay, so the exponential graph, as we know, looks like this, and it has a horizontal asymptote at y equals 0. So that's the exponential function that we've talked about before. Now let's talk about the log graph. Well, the log graph is the inverse of the exponential function. And if you remember, a couple things that we've learned about inverses is number one, we know that all inverses reflect across the line y equals x, and we can also switch the x and y coordinates to get the inverse function on the table. So if I flip these, I'm going to do 1/10, negative 1, 1, 0, 10, 1, and 100, 2. So on the graph, 1/10 is very tiny, and then negative 1. 1, 0, 10, way out here, 1. So I know that it's way out here somewhere. So this graph is going to look like that. And we will actually have a vertical asymptote at x equals 0. So our log graph is going to look like the exponential graph, except it's going to be reflected across the line y equals x. So now let's look at the domain. Well, the farthest left this graph is going to go is it is getting very, very close to 0, but it is never reaching it here because we have a vertical asymptote here. So the domain is from 0 and on to infinity. Or we could say the x value is greater than 0, not equal to because there's an asymptote there. The range, this is going from negative infinity and gradually going up to positive infinity. So that would be all real numbers. We do have an x-intercept. This is going to be a key point on the log function that is at 1, 0. And we have a vertical asymptote at x equals 0. One thing I always remember, exponentials always have a horizontal and logs always have a vertical asymptote. You can think of log L, it's up and down for that vertical asymptote to help you remember. All log functions will have a vertical asymptote somewhere. It can shift left and right, of course, but it will always have a vertical asymptote. So let's look at where we can find that vertical asymptote. If we look at our transformations here that we've done all year, A does the same thing as always. It reflects across the x-axis. It can vertically stretch or compress. H is going to be very important for the log because, as always, it shifts left and right, but that is going to shift our vertical asymptote left and right. And the K is going to shift this key point up and down. So we're going to practice today doing some transformations of our logs and finding these features. So let's look at our first log graph here. This is going to be our vertical asymptote. So we know that the H is always the opposite. So this is going to be shifted to the left 1. So I'm going to draw my vertical asymptote shifted left 1. And this is going to tell me that the key point is shifted down 2. The key point is always 1 to the right of the asymptote. You can see here that this key point is 1 to the right. We're always going to go 1 to the right. And then since it's shifted down 2, I'm going to shift that key point down 2. Another key thing to note about logs is this is the base of the log. The base is not a transformation. It will just affect how quickly this goes over. Just like we have the bases and exponents, the common bases were 10, 2, and e. The same bases you will find are most common in log. Of course, it can be any number. So if there is no base written here, a 10 is implied. If you look on your calculator, there is a log button on your calculator, and if you just push that button, that means 10 because there is no base written there. Any other base would need to be written. So if you're going to have a 2, 3, 4, any other number, just as I have in this example here, we have a base of 2. This is not a transformation, so we do not need to note it as a transformation. It is just the base. So this will always just be the base, just as we had with the exponential functions. Okay, so now that I have enough information, I know that from this key point, it's going to get close to the asymptote, and then it's going to swoop over and gradually grow in this direction. Alrighty, so the domain, it's getting very, very close to the asymptote at -1. So from -1 to, oops, I totally wrote that backwards. The domain is from -1 to positive infinity. The range is going all the way down and all the way up is all real numbers. Notice the range should always be all real numbers for log functions, just like the domain for the exponential will always be all real numbers. So those domain and ranges are exactly flip-flopped for these two functions. We have a vertical asymptote at x equals -1. Remember, it will always be based on what the h is in our equation. Okay, let me get a better pen and try another example with you. All right, this log graph is going to be shifted to the right 1 and down 2. So remember that this is going to tell us where the vertical asymptote is at. So I'm going to draw the vertical asymptote at +1. The key point is always 1 to the right, and I'm going to shift it down 2 because of this -2 right here. Then I can draw my log graph into the asymptote and then swooping over to the right. Therefore, my domain is all the x values greater than, not equal to. The asymptote indicates that it gets very close to 1, but never equal to. The range is going to be all real numbers, or negative to positive infinity, and we have a vertical asymptote at x equals 1. Remember that we always have to write it as an x equals equation because that indicates the whole line. If we just put 1, that's not enough information. That's not an equation to describe where that vertical asymptote's at. All right, last example. We have a vertical asymptote at -2. The key point is always 1 to the right, and this time I'm going to shift it up 2. The domain should be all the x's greater than -2 for the vertical asymptote at -2, and the range again is all real numbers. So that's a little mini introduction to our log functions that we're going to be diving into this unit a little bit more. We're going to be studying more about how to convert back and forth between log form and exponential form coming up soon, and eventually how to solve equations. So this is just a first glance at what does the graph look like and how does it relate to an exponential function.